In this video, I want to talk about average value of a function. Average value of function. Before we talk about average value of function, let's think about this. Let's say your given values 1, 2, and 3, and you want to find average value. How would you calculate it? Well, if you're talking about arithmetic mean, all you're going to do is add all three of them up and divide by how many you have. And in this case, you have three numbers, and this gets you 6 divided by 3, or 2. And 2 makes sense because it is exactly in between or in the center of all three numbers in terms of addition. Now, let's think of a function. Let's think of some function that's going like this. Why don't we choose x squared for simplicity? And you're looking at it from 0 to 2. From 0 to 2. And if someone asks you, what is the average value of this function? Actually, let me make this more to scale so it's gonna make sense later on. 0, 1, and at 2 it should go up to 4. So it should go like this. So what is the average value of this function from 0 to 2? And you may say this function has a value of 0 point something at some time. This function has value of 1. This value has value of 4. This function has a value of 3 sometime. And this value has infinitely many values between 0 and 2 as it's moving from 0 and 2. So how would you calculate the average value? Well, it's gonna be similar to this. You're going to sum up the values. And you're going to divide by how many you have. This may be the first thing you think of, how many you have. So how are we going to represent the sum for this continuous function? Well, if you think about it, if you think of each of these little strips, each of these stick things to represent the value of a function, this stick represents value of 4, this represents a value of 1. If you add up all the sticks, you are going to get the area under the curve. So you are going to get the area under the curve as the sum of the values. But how are you going to figure out how many you have? If you think about this, you have 3 here because you had discrete values. But in this case, you have infinitely many values. So how can we determine how many we have? If you think about it, you're going from 0 to 2. So our length, how far we have gotten, represents the magnitude or the amount over which we are finding our average value. So we're going to represent how many values we have by the length of the interval. And how can you write this mathematically? Area is going to be integral from a to b of our function dx, and length of interval is going to be dividing by length, and length is going to be b minus a. If you're going from 2 to 4, 2 is a, 4 is b, and our length is 4 minus 2, or 2. So this thing is the definition for the average value of a function. This is average value of a function. So let's go back to our example, y equals to x squared, and find average value of this function from 0 to 2. So our average value is going to be 1 over 2 minus 0, our interval is 2, and multiply by integral from 0 to 2 of x squared dx. And this thing is 1 over 2 times x cubed divided by 3, evaluated from 0 to 2. Evaluating it at 2 gets you 8/3 because 2 cubed is 8. Evaluating it at 0 gets you 0. So our average value is 4 divided by 3. And you may say, this value is about 1.3 repeating. It is exactly 1.3 repeating. It's about 1.3. So our average value of a function is about here. That's our average value of a function. And you may say, why is this average value of a function when you're going from 0 all the way to 4? That's not one, that's yes, 4 over 3. When you're going all the way from 0 to 4, why is 4 over 3 our average value? And the answer is because you're spending more time down here then you're spending time here. You're going up faster, but you're spending less less x values between our value of 4/3 to 4. That's why average value comes out to be 4/3. It depends on how much time you're spending down below and up above. So that's our average value for y equals to x squared from 0 to 2.